Hello everyone, today we're going to talk about Coulombs law. So let's talk about the atom first, to understand, basically in atoms, we have to think of basically atoms, right? That's what we need to know. So we have the atom that is and the middle bit, I'm not sure what these particles are called, however, so we have protons, they are charged positively. So protons are positive. And then neutrons, I'm pretty sure, yeah, neutrons. They are charged neutrally, so they're like positive or negative or like zero, something like that. And then the electrons that go around the this part, it is negative. What we also need to know is that one proton is equal to it has kind of like the unit, you know how units have these type of stuff. Basically one proton equals this amount, like it'll be times by something, so there can be like a number here times this, but that's kind of the main idea. And then the same for one electron, so one electron equals the same thing. So let's say we have two atoms, right? I'll call this Q1 and then Q2. So Q1, let's say, is positive, Q2 is negative. So, and we have to know that opposite signs, well, atoms in this case, they attract. Well, it's kind of like magnets. You should know that, that's just basic knowledge. So, Q1 will feel a force towards Q2, and then Q2 will feel the same force to Q1. And these forces are going to be same in magnitude. Magnitude is the number, the force, like how strong it is, I guess. But they're different in directions, you can see, because they're literally going the same way, so they're opposite. And then the formula to find out what the F is, for example, that's what we mostly need it for, is F equals K, which is a constant electricity, something like that. K is equal to 9 times 10 to the power of 9. So that's always like this. K is always equal to this. Just think of K like something that a force needs. Like basically a K is like electricity, something current. Just think of it like that. I'm not really sure what it is myself. Then Q1 times Q2, and then divide that by R2, R squared, and R squared is the distance between the atoms, guys. So yeah, don't forget that's squared, so yeah. And then now this time, let's say we have two atoms and they're like each other, like the same. This time they're gonna repel each other. There's gonna be a force. They're gonna force, right? And they're gonna go opposite directions. Why am I doing it like that? And so this time they're again going to have the same kind of force, but also again they're gonna have different direction. So although they are the same, kind of similar, it is still different. So just remember, protons are positive and electrons are negative. And let's say you have an object and its net force network is positive. That means it has more protons than electrons. Same with the opposite. Let's say the network is in negative. That means then that it has more electrons than protons. Now let's talk about the units. So for force, the unit is newtons. For Qs, the force is in coulombs. And because coulomb is a big number itself, like 1 coulomb is pretty large, in the question you would usually see 1 microcoulomb, which micro is equal to 10 to the power of minus 6 coulombs. And then for 1 millicoulomb, you would do 10 to the power minus 3. So like, for example, it's a 1, right? We do 1 times this, coulombs. And then let's say it's 1 nanocoulombs, 1 times 10 to the power minus 9 coulombs. For R, it has to be in meters, and let's say like in questions you might have it in, let's say it's 1 centimeter. You just do that 1 centimeter times 10 to the power minus 2, because that's what meters are. If it's 1 millimeters, it's going to be 1 times 10 to the power minus 3, because that's like the meters. But also think about it, it's like 1 millimeter, 1 meter equals 100 centimeters. So let's say it will have 500 centimeters, right? The question, you just divide it by 100. Like, you have to do the opposite thingies majiggies. So yeah, also let's say it's 1 meter. 1 meter is equal to 1000 millimeters. So if it's 2k millimeters, it's 2 meters, guys. So yeah, I have a question. So basically, can you please read it yourself, because like, yeah, just read it. So I'll just say that this is micro, and the micro is equal to 10 to the minus 6. Over here it's also micro, and it's negative, and we need to find out just the magnitude of the force. So like, how strong is the force, basically, in like my words. So let's go. So let's just like understand what's going on. 2 forces, right? One is positive, and one is negative. This is like, let's just say this Q1, Q2, right? Q1 is this, Q2 is this, and the distance is 25 centimeters. And let's just straight away convert it to meters. So as we remember, 1 centimeter equals 100 millimeter. No, it's the opposite. 100 centimeters equals 1 meter. So we have to divide this by 100, which gives us 0.25 meters. However, you could just do 25 times 10 to the power minus 2. However, it doesn't really matter right now. So let's work out the force. So, well, F equals K, Q1, Q2, divided by R squared. Also, just a quick notice, these two, they're opposite, so they attract, and the forces in this case, well, as if like in this type of question, they will be equal. So let's just quickly do everything. So K equals 9 times 10 to the power minus 9, then 10, because 10, and then we'll have to times it by micro, because we don't need our answer in micro. And like, when we times it by micro, it gives us the number by itself, if that makes sense. Then 20 times micro, because like 20, and it doesn't really matter, because, so look, we're looking only for the strength, right? And force is a vector. The vectors have directions and strengths. I did a video about vectors. Over here, we're not asking, they're not asking about direction. Also, we know the direction. Oh my god. We know the direction. So we don't need to put the minus in, because like the minus would show us direction, but we don't even need it in this case, so it doesn't matter. And then we divide it by 25, 0.25. And then all of this thing equals to 28.8 newtons. So that's what the forces equal. Also, sometimes what you might need to do, so you need to name the force. For example, this is 1, 2, because so basically this is the force that is going this one. Although it's the same, they have a different strategy. Like these two, there would be different like sides or whatever. This would be 2, 1, because this one is going attracting to this one. So which one it is and where it's going, if that makes sense. So here's the next question. Read it, please. And I'll just say that this time we're looking for the distance, and it's going to be in centimeters. Like we have to then, what's it called? Like transform it into the centimeters because it's usually in meters. But before anything, let's just find out what's going on. So two forces, right? Force 1, force 2. I mean, it doesn't matter which one is which, like, but yeah. Also, nano equals 10 to the power of minus 9. Keep that in mind. They're both positive, so they're going to be repelling each other. And distance we don't know, however we know the forces, and the force is like 15 for like each of them. So just like, yeah, just the force is 15 I mean. Now, scratch, how do we know R? Well, it's basically normal rearranging. So we know that F, which we have by the way, equals K, Q1, Q2 divided by R squared. It's just basic rearranging. Times it by R, R squared F equals K. QQ, 1, 2. Then dividing this whole thing by F, getting rid of the F, then square root, and this whole thing square rooted. This whole thing. So that's how you do it. So we just have to plot in the numbers. So R equals K. Well, first of all, let's do square root. K, which is 10 to the power not minus 9, by the way. Then 800 times... Oh no, I'm sorry. I was wrong. I thought that was nano. But no, K has a positive 9, guys. 10 to the power of minus 9, that's nano, it's definitely minus. And then 900 times 10 to the minus 9. Then divide all this by 15, and all of this gives us 0.0020. No, again I'm lying. 0.0278 millimeters. And we just have to times this by 100 to get in centimeters. So this times by 100 is going to be 2.078 centimeters. So the answer is this. So here's the next question. Please read it yourself, blah, blah, blah. Now this time we're going to look for the actual, what they called, like the value of the Q's. Like the magnitude of the 2 points. Points, what did I say? Yeah, point charge. The 2 point charges. Yeah. So let's just see what's happening. We have the charges, both positive. The reason they're positive is because over here, like, so identical point charges. I mean, we don't exactly know that they're positive. However, we just assume that they're positive because, yeah. And then Q. Let's just put Q2 for now. They repel, and that force is 500 newtons. 40 centimeters, convert it into meters, divide by 100, 0.40 meters. And after that, you're like, okay, how do we look for the Q? Like, again, guys, rearranging. Force equals K, Q. Usually I would write the numbers, but like this time, because they're identical, they are the same number, so we can easily just put it, instead of like writing like this, because again they're identical, we can just write Q squared, because times something by exactly the same is like the same as squaring. R squared, and then rearranging this all stuff, like we can just do times that whole thing by R squared divided by K, so these cancel over here. There is, so basically R squared divided by K. So what we're gonna be having is going to, oh, and also then after that we square root. So the formula is going to be Q equals square root of F R squared divided by K. Both of them are divided because they're on the top. After that, we just use the formula. We know everything. So square root 500, then times it by the r, 40 meters, but squared. Why am I putting but squared? Don't forget it's squared. Divided by the k, which is 10 to the power 9 times, yeah. And then that all equals to 9.428 times 10 to the power minus 5 coulombs, because that's what the Q's are. Q's are in coulombs. Sounds pretty logical, I guess. But then because this number is not kind of what we need, we would usually, like right now, it's not asking us for do it, but we are allowed in exams to like make it our kind of our own way in the ways if we put in our own units. For example, let's change this into micro. So micro is 10 to the power minus 6. So we just, this time we don't times it, because if we times it, that won't add the micro. So you have to understand that to add something, you kind of have to divide it, because when people are going to try to find the water without the micro, they will times it, and like to get rid of it, because that's the difference, because this is times and by micro. So right now we will divide it by 10 to the power minus 6. Hopefully it makes sense. And that will equal to 9428 microcoulombs. So here's the next question. How much electrons represent a charge of 70? So how much basically this, but only electrons, if that makes sense. So first of all, let's convert this to only coulombs. So minus 70 times 10 to the power minus 6, which will equal to, I mean, I'm not sure this is right, because my laptop is like, basically, let's just put 70. Okay, never mind. So let's put yeah. So after this, and then we have to times it by what electrons are value, and 1 electron is equal to minus, because electrons are minuses, basically this, and that's in coulombs, by the way. Like this is, so one electron equals this much coulombs. So in that case, we just times this by that. And then the answer of this is 4.375.
Times 10 to the 14 electrons.
Times 10 to the 14 electrons. Minus. The reason it changed to electrons is because, because we used the right values, it turned it to electrons. So basically, yeah. So read the question, blah blah blah. First of all, let's just actually draw what's happening. So we have a force in the origin, which is the middle. Origin is the middle, and it's 100 microcoulombs, and it's positive, by the way. Yep. And then we have another one, positive, and it is 200 microcoulombs, and the distance between, no, that's not the distance between them. No, actually it is. The distance between these two is 4. The fact that it says negative doesn't mean anything, because that's just the way they are placed. Like, I'll show you. And then there's another one which is a negative now, and it is 50. And so 50 and is 2 meters. By the way, it's good that's in meters. Thank God. So because like there's 3 now, this one, like the left side is usually the negative, so like, and plus these one there are attracted to each other. So that's why they kind of put it as negative, but that doesn't really matter, because even if you like write it as like, you know, in the equation, when you write it, it will become a positive, like 4 times negative 4 times negative 4, the negatives cancel out. So yeah, however, now to find what is the net electric force acting on the 100 micro charge. So to find out it, we have to find out the net electric force, which is basically like the altogether forces for this one. We have to find out what are the force actually acting on it. So first of all, there's a force attracted to this one. It's attracted, and let's just straight away call to like who is going, and then 3 because it's basically this is Q2, Q1, and Q3. Let's just do it like this. This is the one that's also like this one of them, and then the other force is the repellent one, F2, 1. So let's just find out this one, F2, 1. Just like that is in brackets like this. And then we already know the formula. I don't want to write it down. It takes too long. So the K. Why am I doing it now? K, and then 200 times 10 to the power minus 6, because that's the micro, and there's yeah. Then 100, because 200, 100, yeah, times 10 to the power minus 6, and then divide all this by 4 squared, and then that will give us 11.25 newtons. So that is the force for that one.
Exerted on charge 2 by charge 3. So you can adjust the sign Q2 squared. F purely.
Now, I would like to ask you to do the F23 on your own. It's basically the same thing as here. Remember, it's just this time what we do, like because we're looking for this one, it's not Q1 and Q2, it's basically going to be Q2 and Q3. So instead of like you just change the numbers values here because they're both, I mean you don't change this one, you only basically change these two here. So I would like to do it on your own. Write it down, like pause the video, and I'll tell you the answer. The answer is going to be 11.25 newtons, similar to this one, strangely enough. After that, we're able to add them, and that will just equal to, what will it equal to? 22.5 newtons. 50, but 5 is also fine. Because that's the net force, and we did vectors. Net force is basically everything added together. Now, B, like what is the net electric force acting on the 200 one? So over here, it's basically the same thing. We just think about what forces act on it. First of all, the repelling force from this one, and then the attracted force towards this one. So there's this, and we are like basically, oh my god, boom. Let me make my purple. So this is the force that is because of the 2, and this is the force because of the 3. And it's kind of the same technique. 1, 2, and then 9 times. It's basically all that type of stuff. So if I just quickly find the thing. Okay, we don't have to do this one because we already know it. This one is, by the way, in this case now it's going to be a negative. The reason it's a negative because left and right, guys, remember. So it's going left, so it's a negative. And when we're going to add them, it's important because we're adding this one. Over here, they went both positive, so it doesn't matter. So over here, we know it's a negative 11, blah, blah, blah. Now let's do the 3, 1, and the 3 is going to be K, Q1, Q3, R2. Please do the equation yourself because it's a very long equation. I don't want to do it. And I'll just give you the answer, which is going to be 2.5 newtons. And by the way, don't forget, so it's kind of a bad decision that I let you do it yourself. You add these two because we're talking about these, so the R is going to be 6 because we're talking about the whole distance between these two. And then when the net force of these two is going to be like a negative, because like this one is bigger, so basically the net force of this one is going to be minus 8.775 newtons. Thank you everyone, goodbye.